Find the complex numbers w, which satisfy the equation w squared plus 2iw conjugate equals to 1. So you would understand that w just represents what x plus iy is, because that's how you represent a missing complex number. There's going to be a missing real number and a missing imaginary number. Just from this part, when you say there's given answers, there's more than one possible answer for w. So you understand there's going to be 2 possible x values and 2 possible y values. Yeah? Because when x is equal to a certain value, there must be a corresponding y value of that. And likewise, a different x value will have a different y value for that. So long story short, if you know that w is equal to x plus iy, you would understand that this particular equation can be rewritten as, because really you're looking for missing numbers, and if you're looking for missing numbers, you just need equations that represent the missing numbers, and then solve using basic algebra, right? So you have x plus iy, which is what wi squared is, x plus iy squared, w squared, plus 2iw asterisk, which is just what? The conjugate of this, and the conjugate just means, if you're not familiar, recall that if w was equal to 2 plus I, w asterisk, I'm just saying hypothetically, separate example, this would be 2 minus I. You know what this symbol does, yeah? This symbol just turns a complex number, you just change the imaginary component to a negative version. Another example, if z is equal to 2 plus I, z asterisk just equals to 2 minus I. So you know what this does. So without further ado, you understand that this w asterisk just makes it x minus yi. Okay? And the whole thing's still equal to 1. So you turn this into this now. And you wouldn't need to be told, you can simplify this, expand it, right? You get x squared plus 2xyi minus y squared plus 2xi minus 2y. 2 times minus y is minus 2y, times I squared is times minus 1, so which gives you plus 2y. Whole thing still equals to 1. And you have x squared. You group the like terms together. This should be familiar to you by now, because you understand every single number over here. If you have this real number, real number, real number, you would make sense to link those real numbers together. Just out of habit, you'd do that by now. Plus 2xyi plus 2xi is equal to 1. And furthermore, you could say this is, so put a bracket there to make it really clear. This is the real number component, and this would be the imaginary number component, wouldn't it? Also, have a certain awareness for this part. If you see real w less than or equal to 0, remember, all they're really doing over here is not really that different from IG, where they give you information, and using the information here, you can turn those into algebra equations to work out your missing unknowns. You have to take this information, which you turn into this, and this information into whatever they're trying to show to you. They're trying to signal to you that this allows you to find, this is information about what your missing numbers could be. So this particular condition, you would have to understand that if you put RE is a function, it just performs a certain task. Let's just say hypothetically, if z is equal to 2 plus I, if z, so a random complex number is 2 plus I, it's a random complex number, 2 plus I. If you put an REZ like this, the reason why it gives you 2 is it just finds the real number component. This just performs the task of finding the real number component. If you had, say, j is equal to 2 plus 7I, REJ would just be equal to 2. If you had, say, w is equal to 3 minus 2I, REW would just equal to 3. So you get what this does. So what they're saying over here is REW less than or equal to 0. It's the same thing as saying what? REW, so it's really a bracket over there. It's saying the real number component of this missing number we have must be less than or equal to 0. What's the real number component of w? W is equal to x plus iy. The real number component of w is just x, isn't it? So it's the same thing as saying what? The x value must be less than or equal to 0, which is just saying the x value must either be 0 or negative. This doesn't look that relevant yet, but look at this, okay? We have this is equal to 1, which we can get the equation x squared minus y squared plus 2y. It has to be equal to 1, doesn't it? The real number here is equal to the real number over here. This is an imaginary number. There's no imaginary number on the right-hand side. Algebraically, we can tell there's no real number. There's no imaginary number over here, but there's a real number which has a real number component here. There's no imaginary number over here, so there's no imaginary number over here now, is it? It means what? This must be equal to 0, doesn't it? Do you understand that this would have to equal to 0 because there's no imaginary number over here? So you get 2xy plus 2x must be equal to 0. So those are your two equations. And you would understand these are two equations which you can use to solve simultaneous equations. They look very strange compared to the ones you've done before, but you would recognize that in order to solve any simultaneous equation with two unknowns, two missing numbers, two letters, you'd have to rearrange one of them and plug into the other one. You would choose this one. How do you know to choose this one? Because this would be very messed up looking to rearrange for, wouldn't it? You can't find a single expression for this that's very clean. It's not as clean as doing what? You would just know to rearrange this one and plug it back into this one. So when you rearrange this one's a little bit more, you got to be a bit more mindful because look at this. This can be factorized, can't it? What is the significance of this? Because check this out. This, you can, the most common way people would rearrange for this, which is say y is equal to negative 2x divided by 2x like this. And that would give you y is equal to -1, doesn't it? Be mindful of this, because if y is equal to -1, that is not the only possible way you can rearrange this. If you rearrange for the x over here, do you understand that x is equal to 0? A lot of ways you can tell that x is equal to 0. One, if you just replace x with 0, that whole thing would be equal to 0. So you have to understand, long story short, you have to rearrange this to plug it back into here, no problem. But you can't just stop at y is equal to this. You have to be aware that x equal to 0 is also a solution over here. Right? So there's two possible solutions for this. There's two possible ways you can rearrange for this. And both of them give you different answers. Okay? Y is equal to this, you have to keep this. X equals 0, you have to keep this also. So what I'm saying is, when, by the way, you know how x equals 0 is an answer? Because x equals 0 is an answer over here, according to the condition. So the way you do this, you just write when x equals to 0, doesn't this equation become negative y squared plus 2y must be equal to 1? And you can solve that y must be equal to. Just use your calculator quickly if you want to speed run that. Y must be equal to 1. Isn't that one of the solutions? So w equals to 0, because x is 0, plus iy plus I. So w equals to I is one of the solutions. Remember, answers, there's more than one possible solution, isn't it? Another one would be what? When y is equal to -1. Do you see my point? When you rearrange for this, if you only just stopped at y, if you didn't include the x equals to 0 part, you would only find what? You would find that when y is equal to -1, this equation becomes x squared minus -1 squared, which is -1, minus 2y, because plus 2y means plus 2 times -1, minus 2y, equals to 1. Just be minus 2 over here. X squared would just be equal to 4. X is then going to be equal to plus or minus 2. But we ignore what? We ignore the plus 2, don't we? Because this condition over here, this condition means x must be negative or equal to 0. So the only solution we get over here is -2. Let me recap to you, okay? This is so important. Up until this stage, I think you could do everything here. You would just what? You might make the mistake of just only using this, rearranging for the y. You have to also understand that x can also equal to 0. If x can also equal to 0, this gives you another set of solutions over here. If you only use the y value over here, you would only get this number, wouldn't you? You would only get the number of w equals to -2 minus I. Right? Because x equals -2, y is equal to -1, so minus yi, minus I. You would only end up with one of these solutions, whereas you need both of these solutions for the answer. So your final answer was just what? W is equal to I or -2 minus I. Okay? These are your two possible solutions.